Coach Hyde coming at you with Hyde Science videos. Today we're talking about force, talking about weight. All right, man, I'm going to use the force equation. Try to be real quick with this. Keep it about 5 minutes. Hopefully, we'll see how that goes. But just kind of focus on the math of it, how to solve it, how to rearrange it, stuff like that. So up first, force equation. Force equals mass times acceleration. All right, so when you're solving for this, there are three spots, three variables. So we got one for the force, one for the mass, one for the acceleration. All right, so you're just going to plug in things. So if you're solving for force, you're not going to have a value for force. It's going to say what is the force, how much force, blah, 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 right? So we're just going to put an F in, right? If we have the F, we need to have something in both of these. You can only be missing one spot. So we're looking for something with kilograms. This will be our mass. All right, let's say we have 5 kilograms. All right, and we're looking for an acceleration, which is meters per second squared. Let's say this is 2 meters per second squared. All right, in this case, our variable is already isolated on one side of the equal sign, so we're good to solve. So two things together, we're just going to multiply this up real quick. All right, so 5 times 2 is 10. All right, none of these units cancel. All right, if you don't know about canceling, let me know. I'll go over that a little bit. We should be good on that by now. So nothing cancels. So kilograms, meters, second squared. All right, and on our reference sheet, it reminds us that this kilogram meter second squared is a Newton. So this is a correct answer, right? And this is a correct answer, 10 Newtons. Now, so I want to point out, because we talked about the weight formula before. So this is the force formula, this is the weight formula. I don't know how good you can see that, but if you notice, Newtons for force, Newtons for weight. Because weight is a force. It's the force you exert on the ground due to gravity. So these are the same thing. Mass, kilograms, mass, kilograms. It's the same thing. Acceleration, meters per second squared. This is acceleration due to gravity, meters per second squared. These are the exact same formulas. The only difference is you're putting a gravity constant in here, so you should be able to look that up or know what that is. Whereas here, your acceleration depends on the moving of a body. But as far as the mathematics, as far as the solving, as far as plugging in, everything is exactly the same. Now, what if you're looking for something else? Okay. What if you're looking for the mass? All right, let's say we have, 3 newtons. We got acceleration of, 2 meters per second squared. What is the mass? All right. So you'll solve whether you're looking for the mass or acceleration. You're going to do the same process. All right. We have multiplication here. Our variable is not isolated. It's not on the side of the equal sign by itself. So we must move something. All right. Now rules for this. There's 2 rules we have. All right. Do the opposite action of what is already there. So the opposite of multiplication is going to be division. So we're going to divide by 2 meters per second squared. Now, with multiplication, it doesn't really matter the order, so you can divide off the mass or you can divide off the acceleration. If we started with an division problem, all right, like density equals mass divided by volume, then to do the opposite action, right, you have to be specific with what you do because of the rules of math, right? So if you want to know more about that, check out the density problem from Hyde Science, but that ain't this, so let's keep going. So I multiply this, and whatever I do to one side, I need to do to the other side. So I divide it by 2. I'm going to divide by 2 meters per second squared. 3 divided by 2. What's that? 1.5. All right. Now newtons over meters per second squared. If you remember,
biscuits are now ready to be picked up in the teacher's workroom.
A newton is a kilogram meter second squared. So that over meter second squared cancels out our acceleration constant, and our answer is 1.5 kilograms. All right. You would do the same process if you're looking for mass. Or acceleration, I guess, was it? So we'll say this time we got a kilogram, we got a 10 kilogram body. Okay. And we're looking for the acceleration. But it doesn't give you the force. It gives you one of these suckers right here. Now this is a little bit more broken down. We'll say each one of these boxes represents 1 Newton force. So 1, 2, 3, 4, 5, 6. We have a 6 Newton force upwards. we have a 1, 2, 3, 4, 5, 6 Newton force downwards. So we're gonna compare these first. You can kind of think of it as a positive force and a negative force, right? So these are positive forces. These are negative forces. And all that positive negative means is just opposite direction. So what they'll do, they actually cancel each out each other. Each positive force cancels each negative force, right? So there's no net force pulling it up or down. There'll be no motion up or down. Now if we look at left or right, over here, 1, 2, we have a 2 Newton force. Over here we have a 4 Newton force. All right, same thing, you can think of it. You got some positive forces, negative. Again, positive negative just means opposite directions. So these positive forces and the negative forces cancel. So we have a net force of 2 newtons. All right, we're going to take this 2 newtons, and we're going to put it in our equation here. We find the acceleration of this object, this free body or whatever you want to call it. Again, to do this, same situation as last time. We're missing mass last time, now we're missing acceleration, but it's the same process. Our variable is not isolated, so we have to move something. We have to change this equation. So we do the opposite action of what's there, right? Remember, multiplication don't matter the order. So here, this is m, or 10 times a. So the opposite of that is we're going to divide by 10, right? Which cancels it on this side. And then we got whatever we do to one side, we can do the other side. So we're going to divide by 2. Again, remember, newtons is kilogram meter second squared divided by 10 kilograms. I think I know what this is. Just check the calculator so I don't look like a dummy. Should be 0.2, right? 0.2. All right, I'm not stupid. So kilograms cancel. 0.2 meters second squared is our acceleration of that object. All right, and when I say, kind of stepping back a little bit, when I say whatever you do to one side, you do the other side. If for some reason I thought, right, if we were at the beginning, don't do this, but eventually this might be something you need to do in science. It will be. I'll just go ahead and tell you, but not anytime soon, right? If I felt like I needed to double this side, that's fine, right? Multiply by 2, okay? I can do whatever I want as long as I do it over here too. All right, so that's what I mean by that. All right, so that's a really quick rundown. If it wasn't clear enough, let me know. I'll make another one and get a little bit more specific, but I wanted a quick rundown of kind of everything we're going to do with it. All right, science. See y'all later.